So, okay, good morning everyone. So welcome back to my channel. So today video we are going to discuss about the AC/DC and AC converter with the use energy and storage in the DC link. And after that we will guide you how to deploy it, implement it in the Matlab Simulink software. So first of all, we need to see what is the topology of AC/DC and AC PPM converter, and then what is open loop, and then what is the control loop for this kind of converter. So okay, to do that, we will see two papers. The first one is the paper of AC/DC AC PPM converter with the other Lugis and Balasanid from my fellow of E3A. And the second paper is Predictive Power Control upon AC/DC AC converter, which is the predictive one of more control method is the predictive control of the other Joe's Rodriguez and 5 other. So you can download it in the so in order to download it, you can go directly to the VA3 Explore website, and or you can search from worldscholar.com to see all the topic if you wanted, and then you copy and paste this link to the SCI hub to buy it for free. Okay. So okay, let's see the first one, the first paper of AC/DC AC PPM as a converter with the reduced energy storage in the DC link. So figure one here is show the basic converter scheme. We have the input inverter and the output converter, which is the both full bridge converter, include the SiC and IGBT or MOSFET that we already know, and then so we have the closed loop for the feedback of current and voltage. So this paper for us 4 phase in the total. First one is introduction, and the first one you need to see the paper is abstract of this paper. So the paper introduces the family of quasi-direct converters, force of commuted AC/DC AC converter, including the small energy storage device in the DC link. In particular, the case of three-phase to two-phase quasi-direct converter is considered. So after the discussion of the general property of the quasi-direct converter, design critical of both the power and control section are given, and experiment results of the two QVA prototype report. So okay, the first one, the first step is introduction. You see the matrix converter, and then they introduce the control strategies, and the quasi-direct converter has same output performance and component strength as their indirect counterpart, which means the power reserve stability, no need for heavy snapper, no critical timing, but due to the small energy stored in the DC link, the input and output state are coupled. Thus, the input and output power balance must be ensured by the control, which must be fast and accurate. Another control type is to optimize the input performance, so it's often seen in sinusoidal supply current in phase with the line voltage. So okay, next one is the principal provision. So we can see how they speak about the principal provision, the left side and the right side of this bridge, very detailed. And then they talking about the input converter control. So the input converter control is aimed at maintaining a constant DC voltage, respective of the current absorbed by the output stage. And then they talking about the dynamic response. And figure 2 show the small signal block scheme. And the next one is converter design. We have the power section. The power section semiconductor are selected as a for standard voltage fetch half-bridge inverter. And the control section. And finally, we have the experiment results and the actual operation of quasi-direct converter will test on a small prototype design according to approved critical output voltage in 2 kilowatts, supply voltage, DC voltage, output voltage, the rest current, output current, switching frequency, and so on. Okay, so we can refer to this paper to see the overall basic converter scheme. of AC/DC AC converter. And then the second paper is the predictive power control, which is predictive method control. So let's see what they are talking about in this paper. Also, we have the schematic of the AC/DC and AC converter model. We have line rectifier, and then we inverter again, and then we have a load here. Okay, so here is proposed control scheme for the AC/DC AC converter. Because we have the closed loop for the predictive model here. We have the predictive for the current, and then we they calculate about the P and Q component, and then we have to compare with the voltage, and we have the voltage control is a PI controller, and then we have the minimization of the AFP function, and then we have the sigvan here. Okay, let's see. And then we have the sigvan here. This is control the power of this inverter. So okay, so here is also the experiment designs, experimental result of the computer also, and then we have the conclusion. So you guys can download two paper, and then you can go into detail of this paper. And now our job is to create on Matlab Simulink. So okay, you guys, we start a quiz on the Matlab Simulink environment. So the first one is schematic here. We have the AC and DC, AC from AC/DC to DC/AC converter model. So I create the AC, DC and AC converter. And we have the output, the input here is in the AC, the input AC, and the output here, of course we have the AC also. So for the input, we have the three-phase source. So let's see the parameter bit. We will see that this one here, the phase voltage frequency we keep again. So resistance we can change it to 10 AC. And supply voltage is 3, for example, and click it in the specified short circuit level, the basic voltage here, and this one we can change the 5, and then the last phase is weak, and then we can apply, and we can change its name to FITV. 60 Hz and 100 change to amps. Okay. And then the next one we have 3 phase via measured. You can choose the phase 2 graphs, use the label V-grid, because the input is a V-grid also. Okay, so this one we can use label and receive the V-grid also. Apply and okay. And then we can change the name of this one, either grid, and you can connect. And then final one we have device transformer to YD, for example. and we can choose this one into the delta, for example, and this is one. Okay. And then we can connect the edge. This one we can change to finish. For example, okay. And the next one we can choose the rectifier. And then the next one we see we will create the AC/DC AC converter. First one we can create the universal bridge by clicking here and choose the sum number is 100, for example. This one is 0.1, and this one you choose the diode. This one for voltage you can choose a little bit 0, and then measure is device current black. Okay, and this one you can call it to the rectifier. Okay, and this one you can highlight it. Right, okay. And then the next one you can go to tool level converter here, and you click on the switching device. This one you don't change anything. Okay, and this one you can go to inverter. So this one you can flip and left right, for example. Okay, and then you connect it. And of course we have the and then we have the BPM generator to level. Frequency 2000, for example. But this one we choose the open loop first, and this one floats, you can choose the constant 0. Then finally we have the filter here. Before connecting to the load,